Now let's look at the second topic, find the domain of a composite function. Suppose f of x equals 1 over x plus 2 and g of x equals 4 over x minus 1, and then we try to find the domain of each composite function, f composed with g and then f composed with f. So let's look at a first. Okay, f composed with g, that equivalent as f of x is the outer function, g of x is the inner function, right? And then we substitute g of x, which is f of 4 over x minus 1, right? So that's the inner function g of x. So in order to be the composite function have a meaning, and then the inner function g of x have to, make sure the function is defined. So the domain for the inner function, okay, we need to find first. So first step, we need to find domain of inner function, which is g of x. So g of x have a denominator, right? So it has a restriction, which is denominator cannot equal to 0. So x minus 1 cannot equal to 0, which is derived x cannot equals positive 1. Okay, that's the domain for inner function. And then we need to find a domain for the outer function, which is a composite function. So we continue, right? Here we continue. What is f of 4 over x minus 1? So let's plug in this as the x, right, in the outer function. So that's 1 over x plus 2. What is x? X is a 4 over x minus 1. All right, and then we simplify. We both numerator denominator multiply by x minus 1. Okay, so numerator times x minus 1, denominator also times x minus 1. So two term, each term times x minus 1. First term, x minus 1 numerator and x minus 1 denominator cancel out. That's why we only have 4. And the second term, 2, need to multiply by x minus 1 in the parentheses. Okay, and then we simplify as x minus 1 is the numerator, denominator is a 4 plus 2x, right? And then minus 2. So that's 2x minus 2 plus 4. So that's 2x minus 2 on the denominator. Plus 2, I'm sorry. This 2x minus 2 plus 4. So minus 2 plus 4, that's a positive 2. So this is a composite function's denominator. Okay, so second step, we need to find the domain of f composed with g, okay, which is in our case, denominator cannot be 0, right? 2x plus 2 cannot equal 0, and then we can solve both sides divided by 2. So we solve x plus 1 cannot equal to 0, and then solve x cannot equals -1. Okay, so this restriction coming from composite function, and then domain together, right? Domain for the composite function, we need to combine this both restrictions, which is independent variable is x, and x cannot equals positive 1, x cannot equals -1. Okay, there are two values, x cannot equals 2. And then x cannot equals positive 1. This restriction is make sure inner function have a meaning, or inner function is defined. Okay, if denominator equal to 0, the whole expression will be undefined, right? So in order to make inner function defined, and then we restricted x cannot equals positive 1. And then in order to, for the composite function be defined, and then we restricted x cannot equals -1. All right? So again, this is coming from inner function. This is coming from the composite function, which is outer function. So that's how to find the domain for the F composed with G. And then find the domain for F composed with F is very similar. Okay, same process. All right, I want more space. Okay, and then I want to clear this one. All right, now let's work on the B. F composed with F, that's equivalent as outer function is f of x, inner function is also f of x. So now plug in, right, inner function by its definition. And then that's telling us, right, inner function, which is 1 over x plus 2. We have a denominator, right? So from inner function restriction, x plus 2 cannot equal to 0. That's coming from here, right? Inner function domain, which is x cannot equals -2. And the next step, we want to find a composite function, which is plug in, right, 1 over x plus 2. What is x now is 1 over x plus 2, right? And then just like the last one, we simplify. So both numerator and denominator we multiply by x plus 2. So numerator just the x plus 2. Denominator 2 term, each term times x plus 2, right? First term is 1 plus 2 times x plus 2, right? So that's 2x plus 4, which is add 1. Denominator is 2x plus 5. So the second restriction is denominator cannot be 0, right? So 2x plus 5 cannot equal to 0. And then that will given us derive, right? X cannot equals -5 over 2. Okay, so the final domain will be x cannot equals -2, and then x cannot equals -5 over 2. Okay, and then x cannot equals -2, this restriction coming from inner function, and x cannot equals -5 over 2, this restriction coming from composite function. All right, we can check the solution. This is A, x cannot equals +1, x cannot equals -1, right? Second, B, does x cannot equals -2, and x cannot equals -5 over 2, right? So we got both matched solution.